love me. Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.
Hi, hello, namaste, welcome to my channel Max My Heartbeat. How are you all? I hope everyone is doing fine, right? Thank you, and I wish you all a very happy new year and a happy Pongal belated, because I know I'm very late in wishing, but because of some reasons I'm not able to do my videos continuously, but today onwards definitely I will try to reach you as much as possible through my videos. So today, without any delay, let's get started. So in our today's class, let us learn our next concept, that is very important concept for 10th class students, that is similar triangles. Okay, so similar triangles. So before going to similar triangles, we need to know the difference between what is similarity and what is congruency. Okay, so first let us learn about congruent figures, then we'll know about similar figures. Okay, so what are congruent figures? This already I hope some members have learned in their 9th class about congruency of triangles, correct? There our first definition is congruent figures. So what are congruent figures? Figures are nothing but geometrical figures, okay, which have same shape and also same size are called congruent figures. Okay. So some situations will be there in our daily life where we can see the figures having same shape, correct? For suppose we can see a big tree and a small tree. Means the trees like coconut tree will grow very high, right? And some like a palm tree, they grow somewhat shorter. So but those two are similar, means they are trees anyhow. Okay, so that is the best example for similar figures. So congruent figures means I should take two coconut trees. Why? Because they will be of same height, in the same way, same shape, correct? Means both are similar, both are coconut trees and both will be of same height. Clear? When you go to villages or somewhere else, when you are traveling in buses or going to somewhere, in your journey you might be observing some coconut trees in your journey, correct? Gardens, there you can find number of coconut trees, all will be of same height, correct? So there we can observe that they are congruent figures. Clear? Now let us know about similar figures, that is about congruent figures. So similar figures, what are similar figures? So next concept is similar figures. Figures which have same shape and need not be of same size are called what type of figures? Similar figures. Okay, figures which have same shape and need not be of same size are called similar figures. So now all I have said, no, one palm tree and also one coconut tree. Okay, anyhow both are trees, but they are not of same size. Correct? Such figures are called similar figures. So now I am taking two triangles. One is smaller triangle, other one is a bigger triangle. Okay? So here these two are triangles anyhow, but one is a smaller size triangle, other one is a bigger triangle. Means length of each side is smaller here, length of each side is bigger here, but both are triangles. Such type of figures are called similar figures. Okay? Now let us move to our first important theorem in similar triangles. Okay? Now let us move to our original concept, that is similar triangles. Okay? So first concept in similar triangles. First one, we need to know very important theorem. First important theorem, that is basic proportionality theorem. Okay? Basic proportionality theorem. And this theorem is also called as Thales theorem. What is this theorem also called? Thales theorem. Okay? Now let us move to the statement of basic proportionality theorem. One by one I will explain clearly. So I am writing in small now. Basic proportionality theorem. In this, our first one is statement. So learning the statement. Why? Because in 8 marks he will ask the question like this: state and prove basic proportionality theorem. If not state and prove Thales theorem. Means there you have to write statement and proof on our own. No statement will be given in the question. So we need to learn the statement also. Okay? Let us understand. So first let me give some brief explanation about our statement. So in a triangle, okay, already we know that this chapter is about triangles. So in a triangle, a line drawn parallel to one side, okay, a line drawn parallel to one side of a triangle intersects the other two sides in distinct points. Distinct means different points. For suppose I am considering my triangle as ABC. Now a line L is drawn parallel to BC. Okay? How is line L parallel to BC? How it is going? By intersecting the other two sides in distinct points. Means AB is intersected at point D and AC is intersected at point E. Okay? Now what this line is going to do means divides the other two sides in the same ratio. Means AD by DB. AD by DB is equal to AE by EC. Means dividing, this line is dividing these two sides in the same ratio. Means the ratio of AD by DB is equal to AE by EC. Clear? This is the statement. And this is what we need to prove in basic proportionality theorem. Okay? Now, let us write the statement by seeing the diagram. Okay? So, I am not erasing the diagram now. So, by seeing the statement, by seeing the diagram, I will write the statement in my simple words. In a triangle, a line drawn parallel to one side of a triangle of the triangle If not, write one side of it. Okay, parallel to one side of it intersects the other two sides in distinct points and divides the other two sides in the same ratio. Okay, once again, in a triangle, a line drawn parallel to one side of it, okay, line L is drawn parallel to BC, intersects the other two sides in distinct points. So here this line is intersecting the other two sides in distinct points, means AB is intersected at point D and AC is intersecting at point E, okay, and divides the other two sides in the same ratio, means this is dividing these two sides in the same ratio, means AD by EB is equal to AE by EC. Understood? This is the statement of basic proportionality theorem. Okay. Now let us move to the proof. So let us write given, construction and proof step by step. Okay. Now first let me write given, construction, then we'll go for proof and required to prove everything. Next we'll go for proof. Okay. Now first let us write given. After statement you have to write given. In triangle ABC, BE is parallel to BC. Okay, and BE intersects D comma wait. L parallel to BC and L intersects AB and AC in D and E respectively. Okay, once again, in triangle ABC, L is parallel to BC, L is drawn parallel to BC and L intersects AB and AC in D and E respectively. Okay, next construction. So what we need to construct means draw DM perpendicular to AC and EN perpendicular to AB. Draw DM perpendicular to AC and EN perpendicular to AB. Okay, this is about construction. What we need to do? Draw two perpendiculars, one perpendicular to AC and other perpendicular to AB. Next, proof. Required to prove RTP. What we need to prove? AD by BB is equal to AE by EC. This is what we need to prove. Understood? So these are the first three steps which we need to write. First one is given, construction and required to prove. Okay. Next we'll go to our important part, that is proof. So now proof. So proof. In proof, so let us take these lines also. Okay. Join CD and BE also. So now in triangle ADE, first triangle is ADE and triangle BDE. Okay, first one is triangle ADE and second one is triangle BDE. I am taking, wait, first let us take only triangle ADE. Okay, wait, in triangle ADE, I want area of triangle ADE. Area of triangle ADE. So what is the formula for area of triangle? Half into base into height. So half into base. Base is here AD into perpendicular, what I have taken? EN, no, so write EN. In the same way, let us take area of triangle BDE. Okay, area of triangle BDE, this triangle. So here also, now I am taking base BD. So half into base is BD into, now also the height is EN. Why? Because this is an obtuse angle triangle. Even when it is an obtuse angle triangle, we have to take the height as EN only. Why? Because see here, if I draw an obtuse angle triangle, this is an obtuse angle triangle. How can I take the height? From here I can consider, from this length to this length. So here I should take the height outside only. Okay, so here also I should take the height as EN. Okay, so now I am dividing these two now. Area of triangle ADE by area of triangle BDE is equal to half into AD into EN by half into BD into EN. Okay, so numerator half, denominator half gets cancelled. Numerator EN, denominator EN gets cancelled. So what is remaining here? This I can write as AD by BD. This is equation 1. Okay, so from this I got area of triangle ADE by area of triangle BD is equal to AD by BD. Okay, now let us move to our next triangles. I am erasing, why? Because place is not sufficient for me. So now I am erasing this and taking second condition. So now move to our next side, that is AC. So what are the triangles related to AC now? The same triangle ADE and also CDE. Again, in triangle ADE, again area of triangle ADE is equal to, so half into, now the same, but the base I should change now, AE into height is same EN. Wait, sorry. Now the height should be changed. Now what is the perpendicular if I see from here? DM, no? So write DM. Understood? What is the base? AE is the base and DM is the height. Next, area of triangle CDE is equal to, so now half into, now base I am taking as EC into height. Now when I said now, even when it is an obtuse angle triangle, the height is DM only. Okay, now divide. So area of triangle ADE by area of triangle CDE is equal to half into ADAE into DM by half into EC into DM. Okay, so half gets cancelled, DM and DM gets cancelled. What remains here? AE by EC. Now this is equation 2. Okay. So this is half of the problem. I mean 3/4 of the problem. Remaining only 1/4 is there. We'll continue within 2 minutes. I hope everybody understood up to here. Okay. So next, anyhow we got first 2 equations. Now if you observe clearly, triangle BDE, okay, this triangle BDE and this triangle CDE are in between the parallel lines BC and DE only, no? Okay, parallel lines BD and DE and BC are the two triangles BDE and CDE. So I am writing the same triangle BDE and triangle CDE are between the parallel lines. Same parallel lines you mention, okay? Same parallel lines BC and DE. Okay? Triangle BDE and triangle CDE are lying between same parallel lines BC and DE. So area of triangle BDE is equal to area of triangle CDE. Okay, since they are in between the parallel lines, their areas are equal. So this I am taking as equation 3. So somewhere in either equation 1 or equation 2, if I substitute instead of CDE as BDE, then from equations 1, 2 and 3, from 1, 2 and 3, we get. So anyhow, area of triangle ADE by area of triangle BDE will be same. So when LHS are equal, RHS will be equal. Therefore, AD by DB is equal to AE by EC. This is our proof. Hence, proved. Understood? This is the very important first theorem in similar triangles, basic proportionality theorem. Okay? So, if you are not able to understand when I am writing like this, once you listen my concept, then you go through that whatever given in the textbook, then definitely you can understand. Okay? But first concentrate on whatever you are doing. Then only you can get. Only geometry by listening and practicing only we can get. Why? Because this is not just numbers to understand and write. This is a conceptual topic. Okay? So, this is my first concept in our today's class, that is similar triangles, very important theorem, basic proportionality theorem. Okay? I hope everybody understood my concept today. So, if anyone has any doubt in my concept, whatever I explained today, please mention in the comment section. And if you really like my videos, please share my videos to your friends and inform them to subscribe my channel so that they too can learn mathematics how you are doing now. Okay? So that's all for today.